Question 19. I've got an equation for reaction between zinc and hydrochloric acid to make zinc chloride and hydrogen. What is the minimum mass in milligrams of zinc needed to react with 50 centimeter cubed of 1.68 mole per decimeter cubed of hydrochloric acid? I've been given a volume and a concentration, so I need to turn that into decimeter cubed, use my concentration to work out number of moles, then work out that 2 moles of hydrochloric acid react with 1 of zinc, so half it, and then work out my mass from there. So concentration is moles divided by volume. I spotted that because I've got 2 pieces of information about the hydrochloric acid, so it wants me to work out the third unknown. I've got to put 50 centimeters cubed into decimeter cubed. That's a smaller unit value, centimeter cubed, than decimeter cubed. So I'm dividing by 1,000. 50 divided by 1,000 is 0.05. So concentration is moles divided by volume. 1.68 is moles divided by 0.05. Moles HCl, 1.68 multiplied by 0.05, 0.084. 2 moles of hydrochloric acid react with 1 mole of zinc, so over half that divided by 2. Then I've got 0.042 moles of zinc. I know the MR of zinc, so moles is mass divided by MR. Number of moles 0.042 equals mass divided by its MR 65.4. Multiply the two together, 2.75 grams. Taking grams down into a smaller unit value of milligrams, then I multiply by 1,000, 2750 milligrams. My answer is 2.75 times 10 to the power of 3, which is C. An equilibrium mixture is prepared in a container of fixed volume. So I've got an equilibrium reaction here, CO plus Cl2, equilibrium to form COCl. The temperature of this mixture is decreased and the mixture is allowed to reach a new equilibrium. Which is greater for the new equilibrium than the original equilibrium? So, exothermic reaction, so if the reaction is exothermic, that means it's exothermic in the forward direction. So CO and Cl2 forming COCl3. In that direction it's exothermic, in the other way it's endothermic. So if the temperature is lowered, let's think this through, then the reaction will increase the temperature by Le Chatelier's principle. So if you lower the temperature, or try and increase the temperature by surroundings and shift the position of equilibrium to the right hand side to make more heat, to give out heat. So this will not make more CO, so A is incorrect. So the mole fraction of carbon monoxide, if the temperature is decreased, the mole fraction of carbon monoxide, is it going to be greater? No, it's going to be less because the equilibrium will shift to the right hand side. So it'll also make less Cl2, so the partial pressure, that means the pressure of the Cl2, the amount of Cl2 or the concentration of Cl2, the amount of Cl2 contributing to the overall pressure will decrease. So that's incorrect. So that decreases rather than increases. So B is wrong. C, the total pressure of the mixture, is that going to increase? No, it'll make more product. So 2 moles going down to 1, so it's shifting to the right hand side. 2 moles going down to 1 will lower the volume and lower the total pressure, so that's not going to increase. The value of the equilibrium Kp, so how will that affect the equilibrium constant? So the value of the equilibrium constant, making more product, will increase the value of the equilibrium constant because you're making more product, and the equilibrium constant is the amount of product divided by the amount of reactants, or the concentration of the products divided by the concentration of the reactants, or in the case of gases, the pressure of the reactants divided by the pressure of the products. And if you're making more product, then Kp, or the equilibrium constant, will increase.